Hey, everybody. It is 2 hours UTC, and it's time once again for Astronomy Daily Live. So come on in, friends. Join the ever-growing circle of those who, from around the world, are sharing this passion for the universe that we call the science of astronomy. So hey. I've got the coffee here tonight, so a little bit, and it's quite hot. Thank you. And I've got the regular old hydrogen hydroxide HOH. So, yay! I am all set up here. And on the panel once again is Bobby. Hey, Bobby, what is going on over there?
Nothing much. You?
Everything's good. I'm just like I was just saying. I'm really sort of bummed out right now. This Pluto occultation is happening in 3.5 hours. 3.5 hours, and I am socked in with clouds. Just totally socked in. The only thing I can say, two things I can say. First thing I can say is that this is the monsoon season here, and monsoons and clouds, they vanish about as fast as they pop up. So I very well could have a completely clear sky in an hour. So there is still a little bit of hope, but every moment that sort of ticks by, the hope is getting just less and less and less and less. And I'm going to look at my chat. Looks like Tom is over there. Hey there, Tom. Just saw your just saw your tweet, Tom, about the about using the Deep Space Network communications as a science tool. And yeah, I need to check out that video, but that kind of thing I think has been going on for a long time. And yeah, there is some interesting science. I mean, when it comes down to it, it is just light, and so we can sort of treat that light like we do all other kinds of light. And actually, when it comes down to it, most of astronomy is using light, right? Is either measuring light or collecting light or studying light in some way. So those communications that we have with these spacecraft, that radio beam contains a lot of really interesting information that yeah, for sure, can be used for science, right? I mean, for instance, right, we can ask Voyager 2 to send us a number that says how many watts is it transmitting, exactly, right? And then we can receive that data and we can measure how many watts we receive. And, simple 1/r² thing, we can see how many watts we should be receiving and how many watts we actually are. And the difference there tells us things about the material that radio light has actually moved through between the spacecraft and us. And that's extremely interesting, right? It's extremely interesting. So that's just one small example, like off the top of my head. So yeah, I definitely want to view that video. And Tom, if you want to, go ahead and post that over on the Discord server too. And because yeah, I am definitely going to take a look at that uh, later today for sure. While I am uh, waiting for things to clear up here. So Atta is um, in the chat as well. Howdy, howdy. Nice to see you there. And
Yeah,
yeah, hey. So yeah, last night. Well, okay. So that is sort of the first thing that I have to say about this occultation is that really when it comes to weather in southeastern Arizona this time of year, it could literally clear up in the next hour. So uh, I doubt that it will, but it's possible. It's possible. So the second thing that I want to say about this is that you know even though it sort of looks like I'm not going to be able to see this occultation, which sucks. Um, uh, I did get out last night and find this 13th magnitude star, and luckily it was yeah it was about as difficult as I thought it was going to be. I'm relatively experienced in all these kinds of things, so you know basically as long as I know where to point and I have to figure that out. Um, I can usually find things, and in this case, I did. And what I'm happy to report is that 13th magnitude star wasn't quite as faint as what I was expecting. Um, what I was expecting. It was pretty easy to see. Now I did have to use this technique that's called um, averted vision, and Atta, if you don't know about this, listen in. So our retina, right, is primarily made of two different kinds of photosensitive cells. One one type is called cones, and the other is called rods. The cones are sensitive to color, and they tend to concentrate right in the center of our focus. Rods are sensitive to brightness, so it's sort of like a grayscale thing. Um, and rods are everywhere, um, but relative to the cones, there's actually more rods um, sort of, on our periphery vision than there is right in the center. So what you can do to actually improve what you're seeing through the telescope um, with your own eyeball, right, is that you put the object in sort of the center of the field of view and then look off to the side of it, right, but concentrate on that spot, and you will see a significant brightening. Um, and that's because you're using your rods and not your cones. Uh, and so that's what I definitely, I could actually see this 13th magnitude star looking directly at it, but it definitely helped when I looked off to the side of it a little bit. Um, and one of the things that I wanted to make sure I could do was continuously see that star. See, because for an occultation, right, I want to see it, and then I want to see it vanish, and then I want to see it coming back, and so I don't want to. Well, maybe sort of I see it now, and well, maybe I sort of don't, and maybe I do again, and that that doesn't help, right? I need to definitely be able to see it, and then not see it, and then see it again. And I'm happy to report, I'm really, really glad that I am actually able to see 13th magnitude stars with that scope right there, pretty well, pretty well. Not too hard, not too hard at all. Now I primarily use. Hold on, let me get it here. So my go-to eyepiece is actually this one that came with the scope. It's a 25 millimeter Plossl. Right. I've got another one here too. I've got another Plossl around here somewhere that I think I would normally use, but I don't remember where I put it. Up here. Is that it? This one might be it. Oh, yeah, no, that's not it. Anyway, so this is the eyepiece that I normally use, right? Uh-oh. Kitty alert.
Hey, cat.
I opened one of her favorite drawers. She's got some toys in here, and she knows it. So when I open that drawer, she perks up and yeah, she's like, "Oh, are one of my toys going to come out?" I don't think so, kitty kitty. I don't think so. Can you say something in the microphone? No? Just rubbing up against it? Great. Well, we're getting a butt shot now, so thank you so much. Everybody really, really, really appreciates that.
Be careful she doesn't let that webcam out.
Yeah. Oh, it's way over here. So yeah, so that is sort of the go-to eyepiece, and I was actually able to see, the 13th magnitude star with this guy. But actually, what really, really helped, and I'm not a big fan of large magnification, right? I don't really like a lot of magnification, right? This telescope here, the focal length, I think is like 1,000 millimeters, and to compute the magnification, you divide the focal length of your telescope by the focal length of your eyepiece. So 1,000 divided by 25 is 40. So that gives me a magnification of 40, and that's for what I'm doing in terms of looking at things. A magnification of 40 is perfect. It's perfect. It gives me a nice wide field of view and decent magnification, right? But what I used last night is this device. It's called a Barlow lens. Is that going to focus? Let's see if I can make it.
I can see the letters.
Yeah. Anyway, so yeah, I thought that this was a 2x Barlow lens, but I'm looking at it now and it's a 3x, and that makes sense. What I was seeing last night did seem a little bit more magnified than the normal. So it's all this does. It's all this does is it increases the focal length of the telescope by a factor of 3. So what that also does, of course, is it increases the magnification by a factor of 3. It also decreases the field of view by about a factor of 3 as well. So magnifying this a little bit really allowed me to see that 13th magnitude star much, much, much better. Just because it made the star a little bit bigger, right? It didn't make it any brighter. It just sort of made it a little bit larger, so I could see it a little bit easier. So yeah, very cool. So yeah. So if nothing else, I confirmed that I can actually see with my own eyeballs a 13th magnitude star through that scope, and that is something that you know I wasn't too sure that I could actually do. So I'm pretty glad about that. So you know, even if I don't see this occultation, I now know that I can see a 13th magnitude star. And that opens up the possibilities in terms of observing future occultations, probably not by Pluto, but, you know, by just sort of a regular asteroid. So I'm going to just put all this back together here so I don't lose too many pieces. That there. I'm going to put the Barlow back in the special drawer. Oh, she's just behind me. Okay. So yeah, we'll see what happens here in the next three hours or so. As I said, it could clear up still. If it does, I am ready. I'll be able to get onto that star in a matter of seconds, literally. I mean, I'll be able to put the scope down, turn it on, slew right to it. So no problem at all. And that's sort of what I was hoping to be able to do, so I don't have to mess with it tonight, right? Because I mean, if you know, if it clears up, you know, like 30 minutes before this occultation event, I would have had to scramble. I would have had to hurry. I would have had to rush, and I hate doing that. I hate it. I would much rather just not do it at all. So now I don't have to, right? I mean, I can do this last minute, and you know, over the next few hours, if it looks like it's starting to maybe clear up a little bit, I'm going to put the scope out and wait. And as soon as there's even an open hole, I mean, I don't even need a completely clear sky, right? I just need a nice clear hole right there. The star, by the way, is in Sagittarius, so pretty close to Saturn. I actually looked at Saturn last night too. What I wanted to do was, you know, find this occulting star and then move away from it. And so I moved away, looked at Saturn for a little while, and then it's like, okay, you know, I should practice actually going back to that star. And so I did that, and yeah, I mean, it just took a couple seconds. So I am ready. It just needs to clear up.
I thought the idea behind using a barrel was to increase the magnification of a given lens without decreasing the field of view, says Alawada.
Okay, yeah, you know, it's it sort of depends on the optics used a little bit, but you're definitely going to cut down the field of view to a certain extent. It probably won't be, you know, like a factor of 3. I'm probably exaggerating a little bit there, but you are going to have a narrower field of view. Yeah, we should actually uh, get into telescope optics at some point, and work all that through. It's kind of an interesting thing. That moderate, moderately complicated, but you know, I've got the book.
Hey, Uncle Bill, feeling better?
Uncle Bill, how you feeling? Nice to see you in the chat, painting the chat yellow as usual. Anyway, yeah, for those who really want to nerd out on optics, okay, this is the book. This is it. This is the definitive. This is Born and Wolf. Principles of optics, and yeah, you know, you've got to know.
Busy at the office.
You've got to. You've got to know. You've got to know a little math. But look, I've written some notes in here. So yeah, I mean, I've read this dumb thing.
Yeah, Uncle Bill during busy at the office, and Uncle says not as much as you would if you use a higher magnification lens.
Okay, cool.
But thank goodness Uncle Bill's doing a lot better.
Uncle Bill is good but busy. So very cool. Oh, and just as a reminder too, it sort of looks like the live stream for the 18th of August. I probably am going to cancel that. I'm gonna unless it's cloudy. But I'm going to be doing a star party for some coworkers and some friends and stuff. So I'm going to be out and about, looking at stuff. Yeah. So that'll be fun. Put some new batteries in my green laser pointer. So that is ready to go. There it is back there. It's kind of fun to play with these things because you get especially off the CDs, right? Because you get all these cool lighting things going on. So one can just spend hours and hours and hours with a good laser, having all kinds of fun. So yeah, this is really nice. Being green, our eyes are most sensitive to green light. So using a green laser at night, you can actually see the entire beam, right? If you use a red one, maybe a blue one works. I'm not quite sure. But using a green one, so I use this, to point the things up in the sky and say, there it is, right? I don't have to force people, to star hop and say, okay, to see that bright star, okay, then move left to that one and that one and that one. I can say, the object that we're looking at right now is right there. And that makes it a lot easier. So yeah, the only thing, this is very low power. So, it's not going to hurt anything, but you definitely don't want to point this at people's eyes. You definitely don't want to point this at like aircraft because they will come and get you, and you will never be seen again. So yeah, just be careful. But you can get these online. I think $20 or so. They use.
Yeah. And while you're at Uncle Bill, he says OFC. It says, of course, and he has so much time on IMs and start thinking about doing shortcuts for granted.
Yeah, 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 for sure, for sure. So yeah, this laser pointer just uses two AAA batteries, and you just throw them in, positive side down, that, and like that, and then screw this thing back on, and oh, point the right way. There it is. Voila! You can sort of see the beam there. Do you see that?
Oh yeah.
Dusty. Look at how dusty. Ah, that's awful. Oh yeah, there you go. You can see the beam there pretty well. That's impressive. Oh, it's so much fun to play with lasers. So much fun. So many.
Especially when you're
What's that?
especially
Yeah, yeah. Anyway, that's a useful tool for star parties. I've used this for a long time, and it just makes it extremely easy to point to things up in the sky and say that's where that is. Yeah, yeah. Um, uh, um, Uncle Bill, I saw that blue laser pointer. That was pretty intense. So yeah, yeah. You know, uh, if there was anybody around doing like photography and stuff, man, that guy or gal, I mean, would have been tackled and knocked down, and that pointer just smashed on the ground. so so yeah, yeah. Hopefully, it didn't cause too much distress. So, all right. Well, cheers. So we haven't looked at Mars in quite a while. So I thought that we'd go over to the Curiosity Rover website and look at some of the raw images um, that they are posting there. So let's go ahead and do that. And actually, if we come across some, they've got like 6 filters on some of their cameras. So we could actually grab those, put them into GIMP, and play with the colors and see what happens there too. But if nothing else, let's just look around. Mars. I mean, this just blows my mind, right? That we can sit here, right? Sit here in the comfort of our own homes, right? And look at with high resolution, right? The surface of Mars. That's just, I mean, if you think about that, it's just like, really, really, that's amazing. So let's go do that. Let's go do that. I'm going to share my whole screen. I'm going to hide that. And just going off to infinity here. It's kind of fun. All right, I'll stop doing that. I'm going to reload my satellite loop here really, really quick just to see. And you can sort of see here's southeastern Arizona. This is where I am. Right here. And watch. Oh, it's not fair. I'm seeing maybe some thinning though. Maybe some thinning here. But I don't. It just doesn't look very good. So if I was over in Yuma, I'd be pretty happy now. But I'm not. I'm over here. So we'll see. We'll see what happens. So here's the Mars Science Laboratory Curiosity Rover website where it's got all the sort of the latest raw images from all the cameras on this rover, and there are quite a few, right? Quite a few. There isn't just one. There are many, and at least a couple of them are supposed to be used for like stereo vision, right? So like the navigation cameras, there's a left one and there's a right one, so you can see left and right here. So we've got those, so they can look at these things in stereo, and what that does is it gives them a parallax, right? I mean, it allows them to see depth. They can actually measure how far away things are that way. And if you want to be moving around, right, you really need to be able to see depth. You don't want to be, running into like a situation where, you might be going off of a cliff, right? And because of the 2D thing, you can't see it. But with a 3D, you certainly could. But there's other cameras too, more science camera type of things too. And then, of course, we've got the big mast camera, which is the big one that produces all the cool images, coolest images, I guess you can say. And all these images are ordered by Sol, and a Sol is just a Martian day, right? So the Earth day is called a day. A Martian day is called a Sol, and I think it's something like 24 hours and 39 minutes or something like that. So one day on Mars is almost exactly the same length of time as a day on Earth. It's just a little bit more, but they call them sols. Sol. There's lots of pronunciations. I think the proper pronunciation is Sol. So, and then they also have these Hazcams, which they have a couple in the front and a couple in the back, and I think they're basically always pointing down, so they can just sort of see up close if there's anything that's going to mess up the wheels or anything else. So it's sort of looking like they've got images up to Sol 2140 here. That's sort of the latest one. Some of them don't have it all the way up to there, but yeah, 2140. So what we can actually do first is we can go over and see where Curiosity is on the surface of Mars, right? Pretty much right now. We've got these maps. And okay, so this is going through Sol 2132, so we can sort of see where it's gone since then. So this is where Curiosity landed, and this is its entire path so far. And we're right up to Sol 2132, which puts it right there. So yeah, it sort of looks like it went up a little ways, and then yeah, I don't know what it's doing. Okay, 2104, 2102. Okay, so it no, it's a little bit hard to see what's going on here, but anyway, it looks like it sort of went over here, and then it's come back to here. So this is where it is at the moment. Kind of hard to see. This gives a narrow field of view. This gives a wider field of view. So I think here it's been climbing, right? Up and up and up. So yeah, that's basically where it is right now. So that's pretty cool. Gives you a little bit of overview of that. I don't know if they got anything wider. Probably not. Okay, let's go back. Let's go back to the raw images. Oh, one more. Oh, one more. There we go. So yeah, let's just, you know, as I like to do, just sort of follow my nose here and see what's going on. Oh, there's a bunch of images here, so let's just take a look. See, I don't think that the Hascams have any filters on them or anything. I don't think so. I think they're just sort of wideband grayscale. Pretty sure. Let's just take a look and see what those are showing. So not a lot of full frame things, but yeah, we can sort of see what's going on there. You can see the wheels here. I guess this is the front, right? So this would be the front wheels. So this is, you know, gives them a little bit of indication of what's underneath and what's a little bit ahead. All right, so some pretty flat stuff. Maybe some bumpy stuff here. Doesn't look too bad. Doesn't look too bad. So yeah, this is the right one. This is the left one. You could actually combine these and make a stereo view if you wanted. And then all of these here are just subframes. So you know, this is like a full frame. These are just subframes. So they're going to be a little bit smaller. Come on. There we go. Not too bad though. And here's the I think that is the drill, right? Wow, there's a lot of gizmos on that thing. Yeah, I guess you know they're trying to drill into this stuff, and I guess it's really hard. So you know they're having some problems with that. But you know, what do you expect? Sort of looking on the horizon here. I don't know. Is that still some dust? Kind of hard to tell. It's hard to tell. Pretty cool though. So pretty much all the same thing. You know, the cool thing here, right, is that you know exactly when this image was taken. So you can sort of see, right? 2115, 2117, 2118, 2120. So every couple of minutes, they're, you know, firing off a new picture. So that's pretty cool. Then they got these little thumbnails, which are even smaller, right? Come on. Yeah, really small. Not quite sure what they use those for. Don't know. You know, they're so small, kind of hard to see anything. So, yeah, I don't know. Anyway, so that's the... Okay, so there's a left and a right front Hascam, and then it looks like there's a left and a right rear Hascam. So I guess they can do stereo viewing. And yeah, it's kind of interesting that there's consistently like 4 images. That really hasn't changed for quite a while. Oh, here's a couple. I don't know what these are. I guess it's just, yeah, just, you know, when they make a move, they take a picture. That's it. So this is looking behind, of course. So where they've been. There's some sort of bright material there. See that? And there's one of the wheels again. Can't really see the tracks really well. You can sort of see them there, but it doesn't look like there's a lot of dust and dirt and stuff. It looks pretty rocky here, so pretty cool. So let's see. Is there anything else? Let's move on to the navigation cameras. Those are sometimes a little bit more interesting. So what the last place that they have mapped is from 2132. So let's look at those images. So this is going to be the left navigation camera. Let's see what we've got here. And again, I don't think that these have any filters on them, so it's just sort of, you know, broadband grayscale. So there you can see some of the rover here, and rocks and dirt. Oh, here's the tracks. All right, here's tracks from the wheel down there. Pretty cool. You know, I mean, look, people, this is Mars. This is the surface of Mars. We're looking at individual rocks on a completely different planet. It really makes Mars a place, you know, not just a point of light in the sky, but it makes it an actual place, and I think that's fantastic. Oh, here's a horizon view. That might be interesting. Ooh, look at that. I don't know if is this dark thing real? Wow, that's kind of weird looking, isn't it? I don't know if that's just a data dropout or if that's an actual thing. I mean, there's some other dark stuff over here. Here's a little, I don't know, some kind of conical hill. But look at that, just what a landscape. What an amazing landscape. There's some little wavy things here in the sand. Huh. Let's see what else we got here. Come on. So I'm not quite sure what instrument that is. Probably be easy to find out. Here's at least one of the ways that they're able to calibrate their colors, and it also acts as sort of a, you know, where is the sun type of thing. Yeah, this actually might be its power source, right? I'm not quite sure, but that sort of looks like maybe it's nuclear power source. I'm seeing, you know, these heating things off here dissipate the heat. I don't know. I mean, is this all like dust and dirt in here? I don't know. This is probably calibration stuff too, here and here. What an amazing landscape, though. Look at that. Wow. Let's see what else we got here. Another shot of that drill. Trying to dig around in there. Wow, there's some really bright stuff here. Look at that. Overexposed, bright stuff. See down here? It's all overexposed. It's like it's really, really shiny or polished or something. Kind of cool. Yeah, pretty amazing. Okay, that's a smaller little shot there. Oh yeah, downsampled data product, it says. Oh, here's a pretty good shot of the wheel. Got little holes in the wheels. Don't drive over really, really hard stuff. You're gonna damage your wheels. I think they learned their lesson there. So yeah, that's not good, but it's not a showstopper either. I don't know what these little gizmos are here, sticking out like that. I don't know. Wire harnesses and who knows what. Look at that really sharp angle on that rock. Huh. Again, you know, there's really, really bright stuff on here. I don't know what that's all about. All right, let's keep going here. This is fun. So 2132. Let's see if we can. Oh, okay. So 2126. Quite a few more images. Let's just take a look really quick and see anything that catches the eye. Not really. I mean, it's all pretty amazing. Here's a nice, nice horizon shot. Little dusty still. Doesn't look too bad though. Don't really know how far away that is. Really hard to tell. Right? Really, really hard to tell how far away that is. But got to assume it's relatively far. So, you know, we're seeing a little bit of dust. Dust still in the air. That's pretty cool. I'm going to check my chat really, really quick. Make sure that I'm not... Okay, cool. Thanks, Uncle Bill. Thanks, Uncle Bill. Yeah. Cool. Nice. Yeah, and you know, this isn't even the raw data, right? You know, the raw data gets put out in data releases that you can go and grab, like over at the Planetary Data System, and those come out from time to time. You can actually go over there and look. PDS.nasa.gov, I think is what it is. You can sort of see the latest releases. Actually, so Mars Science Library actually just released a new data set on August 1st. And of course, it's from all the instrumentation on the rover, including, of course, the cameras. Let's see, here is the navigation camera, the mass camera. So this is the actual, you know, raw data that you can use for science. These things are just JPEG images, right? So these are just for you know, us peons or nerds, you know, that just like to look at things. If you want to do real science, you go over here and you grab this stuff, which, you know, you have to know formats and you've got to have the right kind of software and everything else. We can just take a look at this though. Okay, this is in a format that makes it a little bit more accessible, but yeah, you know, okay, yeah, I don't know what's going on there. Huh, don't know. don't have a clue what's going on there. That's kind of interesting. I haven't really examined any of this yet, so. But yeah, you know, if you want to do science though, real, actual science, this is the data that you want, and it's freely available, right? I think the only thing they ask is that you mention them. It's like, you know, thanks to, you know, blah, 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 blah for providing the data. Besides that, you can do anything you want with this. This is public data. So, you know, if you want to make a t-shirt, sell t-shirts, you can do that. You can take any of this data you want. You know, put these images on a mug. You can make a poster. You can send them, you know, to your friends, whatever. It's all there. But just for viewing's sake, you know, looking around and stuff, this is good enough. It's a pretty good shot there. Pretty cool. Pretty cool. All right, let's keep going here. So that's the left one. The right one, of course, is basically going to be showing the same kind of thing. I think they do sort of use these camera systems independently. Also, you can sort of tell. 2139 on the left had 10 images. 2139 on the right had 102. So, yeah, they are using these cameras in slightly different ways. Sort of looks like I'm not quite sure what they're doing there. If they're calibrating in some way, I don't know if that's the sun. Hard to tell. Yeah, kind of hard to tell what that is. That almost looks like a flat field to me, right? Because I can see little pieces of dust. So that's probably a flat field. You know, just like you have to do in any kind of astronomical imaging, you got to take your flats. Got to take your flats. So that's my guess as to what that is. I could be completely wrong, but you can sort of see these are probably hot pixels here, pixels that really aren't valid anymore. I'm not really seeing any cosmic rays or anything. Cosmic rays are usually streaks, right? Little lines. I'm just seeing individual points here, but my guess is that that's a flat field. Here's sort of an interesting feature down here, but it's dark, so don't know what that means. Maybe this is an inverse image. I don't know. But it looks like they took a few flat fields, which is good. Probably, well, yeah, for the nav cam, I'm not sure. All right, let's move on here. Gotta take your calibration data. Oh yeah. If you want to do science, you've got to take everything out that shouldn't be there. Yeah, some more calibration data. And maybe this isn't, maybe this is looking at the sun. I'm looking at the dust. I don't know, because I'm seeing landscape here too with the same kind of thing. So yeah, who knows? This is what following our noses does, is it forces us to speculate on things we don't know anything about. But that's fun. Sol 2098. Pretty cool. It looks like they're sort of in the same area. Lots of rocks. Geologist dream, of course. I don't know if you'd call them a geologist, though. Marsologist. Pretty cool looking. So yeah, lots of cameras. Here's the sort of a zoomed in imager, right? Almost like a magnified field of view, just looking at a little portion of Mars. See these interesting white streaks everywhere, blobs of something. Huh. Cracks. Kind of cool looking. Let's see what else we got here. We just sort of scan down here and see. There's 297 of them. Let's see what our chances are here. So something interesting. Okay, so they're looking at a drill hole. I assume that's a drill hole. Yeah, that's a little drill hole, and you see how zoomed in they are, right? I mean, we're looking at pieces of sand now. So that's pretty awesome. Looking at Mars very up close. Very, very, very up close. At different angles. Not quite sure what that is. I don't know. Here's some more drill holes. Looking in the bottom there. Seems pretty uniform. Not seeing a lot of variation in color or anything. But you can see that these images are all sort of in color, which means that this device does, well, either the camera itself is a color camera, and you know, it has, you know, the red, green, and blue sensitive pixels, and then they're just combining them to make a color image, or they have a camera that has at least, you know, 2 or 3 filters on it. It's probably the former. Probably the former. It's probably a color camera. So that's a pretty good looking hole. Well, let's look at it this way. That's a pretty nice hole. I forget exactly how big that hole is. It's not too big. It's ooh, I don't know. I want to say maybe like a centimeter in diameter. I'm not quite sure. Does anybody in chat know how big that is, Uncle Bill? Do you know how big that hole is? I want to say it's maybe about a centimeter or so, but I'm not sure. Okay, so that's a black sand dune that we were looking at. Cool. It's a very unusual shape. And thanks for all the links, Uncle Bill. That's great. Fantastic. All right, let's keep moving here. Let's see if there's any other interesting things with the. So I'm sort of saving what I consider the best for last, and that's the mass cam down here. So let's just sort of let's go way back in time. Let's go back a year. Okay, so 2136, and well, that'll be an Earth year, not a Martian year, but it's a pretty good approximation. So 2136 minus 365 puts us at 1771. So let's go back a whole year and see what these guys were looking at. Don't have one for 1771. We've got one for 1781. All right, they were looking at more rocks. Not a lot of focus there. We got some depth of field things there. Different colored pebbles, I guess you can call them, grains of sand. Again, you know, this is pretty highly magnified. So we're seeing just a little tiny portion of the ground. Pretty cool looking though, you know. Funny stuff everywhere. Martian dirt, there it is. Pretty cool. All right, so let's go over to Masscam and see what we can find here. As you can see, I've already started looking at things, but I'm not gonna look at those again. Let's go back and go back in time a little bit and see what else we've got. So here are those calibration images that they use to make sure they got their colors right. It's very important. And here's where we can actually start grabbing images and put them into GIMP if we want. Hold on one sec. So I was just informed that we've got lightning in the area. So yay, that's just great. Here's the drill. I don't know if that's all banged up or if that's how it's supposed to be, but that's what they've got. That's what they are working with to drill into those rocks. Kind of cool. Nice to monitor those kinds of things. I don't know if this is another bit over here. Not quite sure. It sort of looks like it might be. I know that they can use a number of different tools. So yeah, that might be another one. Oh, here's a sort of a wider field of view. So yeah, kind of hard to tell, I guess. Kind of hard to tell. Here's some wheel tracks. But yeah, that looks pretty beat up. Doesn't that look pretty rough there? Yeah. That doesn't look too interesting. Let's move on. I'd like to grab a few of these images and put them into GIMP and see how we can play with the colors a little bit, but I'd like to find something moderately interesting too. I don't see anything there. These are images of the sun, I believe. So I'm not seeing any color kind of images there. Let's see. How about this one? More calibration stuff. Well, here's these. So we've got these. We've got this. This is sort of mixed up here. All right. There's two different things here. Let's just take a look at this really quick. So this is probably being taken through some kind of a color camera to see how it's sort of pixelized. That's just the individual RG and B pixels, probably like a Bayer pattern. But let's take a look at these things. We've got 1, 2, 3, 4, 5, and 6. All right, and that's probably different filters, although they all sort of look almost exactly the same. There are some differences there. Yeah, I don't know. These look slightly different. But, I don't know. Let's see if there's something, I mean, it's a subjective thing, but I'm looking for something moderately interesting to take a look at here. 2123. Oh, we looked at that already. It's not showing up as being viewed. All right, let's go down a little ways and see. Here's 317 images. Let's see if there's anything interesting there. Pictures of the sun. Nothing too interesting there. Looks like all calibration data. All right. Well, let's go to the bottom just to make sure. Yeah, not much. Interesting rock formation. Again, with this Bayer pattern, it looks like. Kind of cool. You can see those look like layers to me. They might be. All right, nothing too useful there. Striking out here. Luckily, there's lots and lots and lots of data. Let's go back a little ways. What was it, 1770, 1771? Let's go back a year on this one too. Oh, here's one, 438 images. Let's see if anything interesting there. Looks like some, that's pretty cool looking. Don't know how big those cliffs are, right? I mean, that could be a couple of feet. It could be several thousand feet. I don't know. Don't know my scale. Probably isn't several thousand. I would think it'd be a few feet, but hard to tell. But interesting layering here, right? That's at least one of the reasons why we sort of conclude that maybe this is like a sedimentary rock, and these were laid down layer by layer, maybe in water. I don't know. Trying to see if we can get any color images out of this. This just looks like individual images. I'm not seeing any sets of 6 or anything like that, or even any sets of 2. Lots of pictures though. Another Bayer pattern there. Weird looking though, huh? Huh. Looks like southeastern Arizona to me. Look at these weird lines here.
Check the chat.
Check the chat. Check the chat. Hole diameter 16 millimeters. Okay. Yeah. So 1.6 centimeters. Yeah, that sounds about right. Yeah. As I recall, now that you mention it, Uncle Bill, yeah, there is like a wire brush. Yeah, very cool. 20 feet tall. Okay. Cool. Look at that. That looks like a shell. Maybe. And this looks like, oh, who knows? This weird stuff. Weird stuff. It's so easy, right, for our brains to see things, right? That looks like maybe a weird looking shell. This looks like, some kind of a panel with some things on it. Yeah, who knows? But yeah, I think it's all just sort of random rocks. Nothing to get too excited about. Oh yeah, look at those. Wow. I don't know, you guys. This looks a lot like home to me. Pretty cool, though. Look how jaggedy that is. And these really amazing veins through here. Pretty cool. Sort of saw that already. Let's look at this one. Pretty amazing. Gorgeous. As I said, you know, geologists, planetary geologists dream, right? Not quite sure exactly, you know, what kind of like scientific value this has. You know, I mean, I'm way away from geology, so I'm not quite sure, you know, what a geologist sees in all of this. But I can only imagine that you know, it's pretty valuable stuff, useful stuff. Let's see. All right, let's go back here. Let's try. Oh, come on. How about this one? I'd like to make some pictures, but I'm not having any luck today. Calibration data looks like. There's some color images. I'm not seeing. Pretty amazing. Again, I mean, it looks like home to me, almost. We look at the latest ones. Let's look at the latest ones. So I'm not quite sure exactly what sol we're on right now. Is there any info on that? What's new? Mission update. Let's see if we can determine what sol it is right now. It doesn't look like it. Mission update. Okay, so sol 2141, 2142 was around August 13th. So that was a day ago. So yeah, you know, so it's probably sol 2143, 2144 right now. So yeah, that's pretty up to date, right? We're seeing 2140. This was a few days ago. That's not too bad. Let's see. Looks like they just took a couple of pictures. And they're all small. Relatively small, at least. Another hole. Oh, I've got a kitty screaming at me. Oh, here's some more of that bright stuff up here. Pretty cool. That's almost a messy looking hole, right? It's not a clean hole. Looks pretty messy. Mars is just amazing. I can't wait until, you know, we can see, you know, the surfaces of other moons and planets like this. It would be fantastic. Here's a couple days ago. Pretty amazing. All right. Well, there is Mars. It's, you know, I like to visit Mars from time to time, just sort of see what they're seeing, sort of, you know, my way of following the mission around a little bit. So very, very cool. But I think it's about time. I'm just going to check the chat here really, really quick. And yeah, Yeah, you know, a lot of that stuff does have to do with how how the lighting is, perspective, and all that. Because these human brains, right? I mean, we seem to be wired to want to see patterns, right? We want to be able to see things, and so even in completely random stuff, these brains of ours will see all kinds of stuff, right? I mean, you just have to look at clouds, right? And we see all kinds of stuff that you know, it's things look like a lot of things, but it's not as if those things are actually there, right? We're just sort of seeing them. All right, well, cool. I think I'm going to get out of here for today. So thanks for coming in. I'm going to check my clouds. What I've got about another 2 hours until the occultation event. It's happening about 5:33 UTC, and right now it's what 3:17. So yeah, a couple more hours. We'll see. We'll see. Um, Looks like my camera isn't focusing. I'm going to focus on my wrinkly hand, and then I'm going to should pop in. There we go. There we go. All right, you guys, I'm going to get out of here for now. So thanks for coming in. Thanks, Bobby, for being on the panel again. Um, yeah, let's do this again tomorrow. One more spin of this little tiny little planet, and we will meet here again and do something else astronomical. Never really know what I'm going to talk about until I basically start. Sometimes I have ideas, but oftentimes I don't. And that's just sort of the fun part of this. We just sort of follow our noses and see where it goes. All right, you guys, I'm going to get out of here for now. Take care, and I will see you in a little less than 23 hours. All right, bye.
Later.